Section 8.1, Simplifying, Multiplying, and Dividing Rational Expressions. So a rational expression is just a fancy way to say fraction. And when we are simplifying these fractions, we can only cancel out factors and not terms. Now, a factor is something that is multiplied by the rest of the rational expression. On top, if I have 5 times x plus 3, x plus 3 and 5 are both representatives of factors. Terms, remember, are something that is added and subtracted within a rational expression. So we cannot cancel out something that is added or subtracted. This is a very common mistake, so it's important that you understand the difference between a factor and a term. So I have an example here of simplifying x squared plus 5x plus 6 divided by x plus 2. I'm going to show you how we should do it, and then I'm going to show you a non-example of how not to do it. And the non-example is something that we see a lot with the mistakes that students make. So how you should simplify a rational expression is you should factor first. So we have x squared plus 5x plus 6 over x plus 2. Now the bottom cannot be factored anymore. It doesn't have any more exponents, so there's nothing there to be factored. However, the top, we can use our box method to factor it. A times c is 6. The factors of 6, 1 and 6, 2 and 3. And we want something that will add to be 5 and multiply to be 6. So we want all of our factors to be positive. So I have 2 and 3 that would work. So if I were to put these into the box, remember my first term goes in this box, my last term goes here, and I have 2x and 3x that would add to equal the 5x. I can take an x out of the top and a 2 out of the bottom. The left side, I can take an x, and the right side, I can take a 3. So my factors are x plus 3 and x plus 2. Now, I suggest to you that you put all of your factors in parentheses, at least in the beginning, just to remind you that only things that are inside a set of parentheses are factors that can be canceled. So when I'm looking for something to cancel, it has to be identical factors on top and the bottom. X plus 2 is a factor on the top, and x plus 2 is a factor on the bottom. Therefore, both of those can cancel. Now what's left is just x plus 3. So if I were to simplify this rational expression, the answer would just be x plus 3. All too often when I see students trying to simplify, I see them trying to simplify the terms and not the factors. So again, here's our equation, and this is an example of how not to do it. But I think it's important for us to see what not to do in order for us to avoid what the common mistakes that may happen. So what you should not do is you should not take a look at the 6 and the 2 and go, oh, I can reduce those by 2. And that makes this a 3 on top and just a 1 or nothing on the bottom. And I can take one of these x's out, leaving me with x plus 5x plus 3. And I have just a 1 on the bottom. So a lot of people would try to simplify this to just 6x plus 3. Notice they're not even close to the same. This is not how we should do it. And that's because we went down the path of trying to simplify terms and not factors. Terms because they're addition and subtraction, not factors that are multiplied. All right, our first example. we're going to identify all of the values for which this expression is undefined. So in order for something to be undefined, generally we have to have either a 0 in the denominator or something happening underneath a radical. So since we're dealing with rational expressions, we're always going to be looking for what is going to make that denominator equal to 0. Think back to chapter 6 when we did division of polynomials, and we always had to identify what's going to make that denominator equal to 0. So in this case, in order to find what's going to make this undefined, I need to find out what's going to make underneath this fraction bar equal to 0. So we are going to factor the bottom. There's quite a bit of factoring in this chapter, so you need to dust those skills off and make sure that they're nice and fresh to be able to work through this chapter and be successful. So I am going to set this up to go into my box. That means that my a times c is equal to negative 28. Factors of 28, 1 and 28, 2 and 14, 4 and 7. And I want them to multiply to be a negative and add to be a negative. So I'm going to want the larger factor to be negative. The smaller factor will be positive. 4 and negative 7 add to be my negative 3. So I have x squared, negative 28 for my first and last term, and then 4x and negative 7x go in the opposite boxes. I can take an x out of the top, a 4 out of the bottom, an x out of the left, and a negative 7 out of the right. So my factors for the bottom would be x minus 7 and x plus 4. Now, if I want to find out what's going to make the denominator equal to 0, after I have these factors, I'm going to set each of those equal to 0. So if x minus 7 equals 0, that means that x would be 7. And x plus 4 equals 0 would mean that x would equal negative 4. Now, when you set this up back in the original problem, always check to see if something can cancel, because when things cancel out, then we give them a different name later on in the chapter. Now, in this case, it doesn't have anything canceled out. But if, let's say that the x plus 7 canceled out, we would still have to indicate that the denominator could not be that negative 7. So it's not really applicable for this particular problem. However, in the future, you need to always make sure that even if you cancel out a factor, you still need to indicate that x cannot equal that number. Now, let's work on simplifying some more expressions here. Remember, the first step in simplifying these expressions is always to factor. And when we factor these, we're going to factor the top and we're going to factor the bottom of each of them. So for the first problem, to factor the top, we need to do a times c, factors, and we want them to multiply to be a negative, and we're going to make them add to be a negative as well. So our larger factor will be negative. And that indicates that we should be using 3 and negative 8 for our factors. So I have x squared and negative 24 opposite, 3x and negative 8x. The top, I can take an x out. The bottom, I can take a negative 8 out. The left side, I can take an x out. The right side, I can take a 3 out. So my factors for the top are x plus 3, x minus 8, Now the bottom, you can go through the whole box method, or you can choose to remember your pattern. Those are two perfect squares, and they have a minus in the middle. That means that they should factor to the square root of the first term, the square root of the last term, 1 plus, 1 minus. Once everything has been factored out, then you're going to look to see what terms are in common on top and bottom. So I have an x minus 8 on the top and bottom, so those cancel out. And I'm left with just x plus 3 and x plus 8. Look at B. Now remember our first step, factor the top, factor the bottom. When we look at the top does not factor, doesn't have any exponents that I could try to break down or anything of that sort. But the bottom has a couple of things that we can do. The first thing that we can do is we can take a 3 out of both terms. So I have a 3 and c squared minus d squared. The second thing that I should notice is that, again, they're two perfect terms, two perfect squares with a minus in the middle. So they factor down just like we did over here with the x squared minus 64. So I have c plus d on top, 3c plus d, and c minus d. Again, that pattern, if you're still learning it, is the square root of the first term in the first spots, the square root of the last term in the last spots, 1 plus, 1 minus. So this c plus d, this whole thing represents a factor. So I'm going to choose to put it in parentheses. Again, this is a step that you only probably need to do maybe for a few problems until you are trained to know this is a term, this is a factor. So I have a factor on top and 3 factors on the bottom, and I'm checking to see are any of those factors the same. And I see that the c plus d's are the same on the top and the bottom. So when I've canceled those out, I'm left with nothing on the top. That doesn't mean that there's actually nothing there. What's really there is a 1 to hold the place. And that's because, remember, there's still an invisible 1 in front of this factor. That's the coefficient of the factor, if you will. So there's still something there. Canceling something out doesn't make it go to 0. So I have a 3 and a c minus d. And it's not necessary for you to distribute that 3 back out. I'm okay with you leaving your answers as factors. In fact, I think that that's encouraged. Take a look at C. Now for C, we're going to factor the top. It's 3 terms, so we're using our box method. So I have negative 40, factors of 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8. And I want it to multiply to be a negative, but this time I'm adding to be a positive. So I want my larger factor to be positive, which will make my smaller factor negative. The one that adds to be positive 3 is negative 5 and 8. Setting up our little box here. Y squared and negative 40 go opposite. And then my negative 5y and my 8y go in the box. Doesn't matter which one. On the top, I can take a y. The bottom, I can take a negative 1. The left, I can take a y. And the right, I can take an 8. Oh, that should have been a 5. Which means I could have taken a negative 5 out. My mistake. So I have y minus 5 and y plus 8 for the top. In factoring the bottom, I notice that there are 2 perfect squares with a minus in the middle. So that pattern is repeated yet again. So it really is in your best interest to memorize that pattern and familiarize yourself with it. Be very careful when you factor this out, because you have to follow the pattern. Do not just blindly put the y in the first spot. In this case, the y is in the second spot. So if we follow the pattern of square root of the first term, that's 5. That goes in the first spot of each of these. The square root of the last term is y. And we make one of them as plus and one of them as minus. This is not the same thing as saying 5 plus y and 5 minus y. They are two separate things being factored there. Now, because of this, we also cannot look at the factors here and say, oh, those are the same, or these are the same, because in both cases, the y or the 5 presents a sign error. The signs are not the same. So my suggestion would be to reverse the y and the 5 on the bottom. But when you reverse it, be careful that you follow along and keep the signs the same. So if I were to reverse this, it would be positive y, positive 5, because they were remaining as positive. But here, reversing it, I have a negative y and a positive 5. Now don't get discouraged or fooled in this case. There will still be something that you can do to make these cancel. Right now, I don't have anything that matches up. But what could I factor out of this to make both of the signs match up here? And the answer to that is a negative 1. So that would make this negative 1 factored out. And I like to put it all the way in the front, just because I think it looks kind of silly in the middle. Here's our y plus 5. And when I factor out that negative 1 here, that becomes a positive y, and that becomes a negative 5. Now, the reason why I can do this is because if I were to FOIL all of these back out, I would still get to what I started with. So the bottom of my expression is now negative 1 times y plus 5 times y minus 5. And I can see that the y minus 5s are the same, and they cancel out. So what I'm left with is y plus 8 over negative 1 times y plus 5. Next example here, example D. For example D, I look on the top and I know that the first thing I can do is take out an x out of both of those terms. So I have x, a squared minus b squared is left. And when I look at the bottom, I notice that I can take a y out of both of those. So y, then I'm left with b minus a. I know that that a squared minus b squared represents, again, that pattern that we've seen in the previous 3 problems, 2 perfect squares with a minus in the middle. So I know that it's going to factor to be x, or a plus b, and a minus b. And then my denominator is still y, b minus a. The next thing that I notice when I'm trying to cancel out these factors, and again, the x is a factor, the y is a factor, a plus b, b minus a, a minus b, those are all factors, is that they're not quite identical. The first thing, again, that we notice is wrong is that the a's and b's are in different spots on top and bottom. So we're going to reverse the bottom. That means I'm going to put a first and b second. Make sure you keep their signs the same. That's a negative a and a positive b. Now it's not quite the same as what these are. So we're in the same boat that we were over here. We're going to factor out a -1. See if that can get our signs to be the same. So I still have that y hanging out in front. This time I'm factoring out a -1. I still have the y. And when I factor out that -1, it comes to positive a and a negative b. Now I can see that I have a minus b on top and bottom, and they cancel out. So I'm finally left with just an x, an a plus b, and then the bottom, all I'm left with is the -1 times y. All right.